Now 13 students, me and my ironback here are going to talk to you about section 3.3, measures of relative standing and box plots. So go ahead, follow me over here to my other screen. So let me go ahead and share. There we go. So section 3.3, measures of relative standing and box plots. Here's some technical detail to help us. All right, a little bit of an outline first. We're going to go ahead and demonstrate how we find summary values. We actually already know the keystrokes. I'm just going to call those values out on our calculator. We'll look at that in a moment. We'll get our calculator to draw a box plot for us, which is always fun and exciting. Then we'll talk about Z-scores, what they're good for, and we'll look at an example or two there. So come on with me and we'll go ahead and get started. Example number 1. We have a random sample of same-store customer counts. So how many people visited a particular store? Well, here we go. Anywhere between, let's see, we got 350, 460, only 20 on a given day, and so on and so forth. So these are the number of people that have visited a particular store. We're going to go ahead and answer these questions. We're going to find the quartiles. You've already seen me introduce those in the previous presentation for the material in 3.3. as well as the 5-number summary, and then we'll go through the keystrokes for finding and getting our calculator to draw the box plot for us. So, first off, our 5-number summary. Let's go over here to our calculator. Under Stat and Edit, I'll remind you, is where our data usually lives. I have my data in list number 1, so I'm going to go ahead and access calculation, the 1 variable stats. I'm going to point it at list 1 and then hit enter. So now my calculator is going to go out and find a number of different things for me. We got the mean, the standard deviation, and so on and so forth. On the second screen, we have the 5-number summary. That 5-number summary consists of 5 numbers. The minimum number, 20, that was the lowest value in that data set. Q1, 180, the median, or Q2, depending on how you want to notate things, is 270. Q3 is 420, and then the maximum value is 580. So my 5-number summary are just those values there. Now, we'll want to go ahead and find the quartiles. These are the values that divide the data set up into quarters in terms of size or number of data points. So the first bit will contain 25 data points, 25% of the data points. The second bit, 25%. The third bit, 25%. And the fourth bit, 25% also. Now, to do that, we need the quartiles. Interestingly enough, your quartiles are right here, Q1, Q2, and Q3. Now, why only 3 numbers? Well, we don't need to define the lowest number because that's the minimum value. We just need to define the division between the first and the second quartile, second and the third, and then the third and the fourth. So, Q1 is 180, Q2, 270, Q3, 420. You see them listed there. It's the middle 3 numbers. Now, finally, we want to draw the box plot. The box plot is a summary, basically, of those 5 numbers we find in the 5-number summary. Let's go back over to our calculator and see how it gets the job done. Now, over here on our calculator, I'm going to go ahead and clear the screen so we've got a nice, clean starting place. Here in blue, I see stat plot. We use a lot of commands that live up there in stat plot. That's basically where we go to get our calculator, for the most part, to draw the nice pictures for us. So I'll hit stat plot, and I'll notice plot number 1 is turned on. This is basically what we want to see. I'm going to hit enter to bring that command up and all those little sub-commands that go along with plot number 1. So it's currently turned on. I could turn it off if I needed to. Sometimes that's important, but I really want to make sure it's turned on right now because I want to see the picture. Now, I'll scroll down one line to the various types of graphs my calculator is capable of drawing. using my arrow key, I'm going to scroll through until I find this particular one here. Now, if you've done the homework, if you've already looked at the material somewhat, if you've read the book and taken a look at the PowerPoints, you already know that this is what a box plot looks like. So I've selected that particular box plot there. And then XList, list number 1. This is where you have to tell your calculator where the data lives. Second, number 1 plugs in list 1. All of the things being equal, you should leave the frequency at 1. You really shouldn't need to adjust that at all. Now, when it comes to drawing graphs on your calculator is very, very sensitive to the domain and range that it's trying to display. This goes all the way back to algebra. We don't have to do that here, but we do need to acknowledge that the plane is vast, the picture is small, and we got to look in the right place. Now, our calculator does that quite well. Watch these keystrokes here. We're going to use them later this semester. I will remind you of them. Now, over here, underneath Zoom, under 9, I have Zoom stats. So I'm going to select 9, and it's going to pick the correct X and Y values to draw this box plot for us up here. So there's a picture of our box plot. I can play around with it a little bit. Using the trace function, I can pick up the 5-number summary. The median, or Q2, is 270. And then using my left arrows and right arrows, I can scroll through the box plot. And as I do, down here in the corner, you'll see those values appear for the 5-number summary. So I can access those values there. I don't see them in the picture, but I can get ready access to them. So let me go ahead and clear that out. So your box plot, there you go. I plugged in a picture of that right there. Now, that's the first topic on our list. The second topic is the Z-score. This is another measure or another way to calculate position. It turns out to be quite important. We're going to use Z-scores and their brother, the T-score, later this semester quite a bit. I'm going to start with the definition because it is so important. Now, you've already encountered it in the 3.3 presentation and in the material in your book. But it's worth remembering that the Z-score gives you the number of standard deviations. A particular value is either above or below the mean. We like to round our Z-scores to 3 decimal places. Our book's a little wonky on that, but I guarantee you 3 decimal places will be what we'll use all semester long. Yes, there is a formula here, and no, it is not built into your text. Now remember, our exams for the most part are open notes, so making a note of that particular set of formulas might be important later at some other time, say during assessments. Now, we have one formula for sample Z-scores and another formula for population Z-scores. The formula is identical. The only difference you can see there is the difference in notation. And it's worth calling out X bar and S for your sample, mu and sigma for your population. So we do honor that notation when we can. I'll use that formula. I'll run through the calculations on the calculator in just a moment. Why do we like the Z-score so gosh darn much? Because it helps us find significant values, and it's quite flexible. This is why we like to use it. It does the same thing that the mean plus or minus 2 standard deviations does for us that we encountered back in 3.2. But it's more portable. X values that are significantly low have a Z-score less than or equal to -2, while those that are significantly high have a Z-score greater than or equal to a +2. In terms of a pretty little picture, you can see as far as your Z-scores go, -2 or less, those X's are low. +2 or higher, those X's are high. So let's take a look at an example now. Oh wait, no, let's take a look at some properties first. And again, you've seen this slide before, but I do want to run through it because it is important. As pointed out, the Z-score is the number of standard deviations above or below the mean that a particular value might lie. Because of this, and if you chase through the the units in the calculation, you'll find out that they actually cancel out, and we like to call Z-score a score with no units or dimensionless in some languages. We like to have it define our significant values. It's positive when the X value is greater than the mean in question, and the Z-score will be negative when the X value is less than the mean in question. Now, example number 2. We're going to use that same data. There it is. So it's the number of people that have come into the store on any given number of days here, randomly selected. We're going to find the Z-score for X equals 380. And then we're going to answer 2 questions. We're going to answer the question, well, it's 380. That's a fairly large number. Is that significantly high? And then I want to explain the rationale for that, the justification, if you will, in 1 to 2 complete sentences. Oh dear, I have messed up the slide here, but that's okay. So if we want to find the Z-score for X equals 380, I'm going to need the mean. Oh, let's go back over to our calculator, clear things out. Remind ourselves that we can calculate the mean of a given data set with just a couple of simple keystrokes. I round to 1 decimal place, so 294.2 is my mean. Standard deviation, 167.2. 167.2 here. Now, when I plug that into my formula, this is what happens. And I do apologize for the ordering on the slides. I'll fix that for next semester. Bad, Chris. So coming over here, let's see how this works. And I think these keystrokes really truly work best for my students. We have 380. We're going to subtract a 294.2. I'll hit enter. I'll get my numerator, and then I'll divide that result by the 167.2. I'll hit enter one more time, and I'll round that to 3 decimal places, 0.513. There we go. All right, so I've calculated the Z-score of 0.513. Now I can answer the question, is that significantly high? No, it is not significantly high. Well, justify yourself, Chris. Well, all right, I will. We want to explain why it's not significantly high in 1 to 2 complete sentences. Well, it's not significantly high because the Z-score is not greater than or equal to a positive 2. If we had a Z-score that was greater than or equal to a positive 2, yes, we would then have a score that was significantly high. For the sake of argument, if I jump back over here and I plug in a value like, say, 700, that wasn't even part of our data set. But if I plug in the value of 700 and I subtract the 294.2, and then I divide that result by the 167.2 of the standard deviation, this gets me a Z-score of 2.427 and change. 700 would be a score that would be significantly high. There we go. So this is one way we like to roll with this. The Z-score will do other things for us also, but at the end of the day, the first and most important thing it does for us is identify something that is truly significant, either on the high end or the low end, when compared to the mean of whatever set of numbers you're looking at, scaled by the standard deviation. That's that denominator of either S or sigma. All right, so if I can summarize now, we've demonstrated finding some significant, or excuse me, summary values. We took a look at the box plot graphs. We found a Z-score. In fact, we found 2. And then we used that Z-score to identify values that were either high or low, or perhaps neither. Thank you. That's the end of this presentation. Let me stop the sharing and say goodbye. And we'll see you a little bit later for material from chapter 4.